So let's talk about Kubernetes. It's an incredible piece of technology, right? But with all that power comes a whole lot of complexity. Your applications are running, but it can often feel like they're inside a black box. To really get a handle on these systems, you can't just run them. You have to be able to see inside and understand them from the ground up. So, in this explainer, we're going to do just that. We're going to crack open that black box. We'll start with why it's a black box in the first place, then look at the pillars of observability, see how data actually gets collected, touch on the industry standard tools, and then get into the future of monitoring with operators. All right, let's set the scene. You've deployed your app, Kubernetes is doing its thing, scaling, self-healing. It feels like magic. But what happens when something slows down or just breaks? That magic can turn into a real nightmare fast. And that leads to the big question every single engineer has to face. What is really going on in there? Are my pods healthy? Are they gobbling up too much memory? Is there one little microservice that's causing a huge bottleneck for everything else? If you don't have that visibility, you are quite literally flying blind in production. I love this quote from Kelsey Hightower because it really hits on a core principle here. Monitoring isn't some feature you bolt onto Kubernetes later. No, it's part of its DNA. The whole system is actually designed from the ground up to be observed, and that's what fuels all its powerful automation and self-healing features. So to really understand what's happening, we have to move past simple checks like, hey, is the server up or down? That's just not going to cut it anymore. And this is where this idea of observability comes into play. Look, observability is more than just a buzzword. It's a totally different mindset. It's about having the ability to ask any question you want about your system without needing to know in advance what you are going to ask. And it's really built on three key pillars of data. First up, we've got logs. Think of logs as the story of your application. They are a blow-by-blow chronological stream of events telling you exactly what happened and when it happened. When a pod inevitably crashes, the very first thing you're going to do is check its logs to piece together the story of what went wrong. Then you have metrics. So if logs are the story, metrics are kind of like the vital signs, the heartbeat of your system. These are all the numbers measured over time. Things like CPU usage, request latency, memory consumption. They are perfect for building dashboards, spotting trends, and really importantly, for triggering alerts when things start to go sideways. And pillar number 3, tracing. In today's world of microservices, a single click from a user can set off this huge chain reaction across dozens of different services. Tracing is like the detective that follows that one request through the entire maze, showing you exactly where the time is being spent and helping you pinpoint those sneaky performance bottlenecks. So to sum it up, each pillar gives you a totally different lens to look at your system. Logs tell you what happened. Metrics tell you how is it performing right now. And traces answer the question, where is the bottleneck? To get the complete picture, you really need all three. Okay, so now we know what kind of data we want, but in a massive distributed system where nodes are spinning up and down all the time, how do we actually get our hands on that data reliably? Let's peel back the onion and look at the mechanics of data collection. It all starts at the source, right? By convention, our containers are just writing their logs to standard output and standard error, simple as that. And for the resource metrics, like CPU and memory, every single node in your cluster is running a component called the kubelet. And built right into the kubelet is an agent called cAdvisor that is just constantly collecting those vital stats. But here's the challenge. Collecting the data locally is one thing, but you have to aggregate it. You need some kind of agent running on every single node to ship these logs and metrics to a central place. So how do you make sure that agent is always running, even when new nodes join the cluster? And this is where the sheer elegance of Kubernetes just shines. The platform gives us the perfect tool for this exact job, the daemon set. You just tell Kubernetes, hey, I want this specific pod to run on every node, and the daemon set controller takes care of everything else for you, automatically. And here's what that looks like in the real world. This is a manifest for a Fluent logging agent. You see right there, we define the kind as a daemon set. And Kubernetes just knows, okay, I need to deploy this pod everywhere. And check out the volume mount section. That's how the agent gets access to the host node's log directories to scrape the logs. Pretty neat. So our agents are collecting all this data, and they're sending it somewhere. But where is that somewhere? Well, for metrics, the cloud-native community has pretty much decided on one tool to rule them all. Let's just be really clear. If you work with Kubernetes, you work with Prometheus.
It's an open-source monitoring toolkit that was practically born for the dynamic, messy, service-oriented world of containers. Its query language is incredibly powerful, and it integrates seamlessly with Kubernetes service discovery. I mean, think about this. It was the second project ever accepted into the Cloud Native Computing Foundation, right after Kubernetes itself. That tells you how fundamental it is.
A key thing to understand about Prometheus is its pull model. Instead of having applications constantly push data to the monitoring system, Prometheus actively reaches out and scrapes metrics from an application's HTTP endpoint. This makes service discovery in a dynamic environment so much simpler and more robust. And this is what you get from all that scraping. Beautiful time series data. It's this continuous stream of measurements over time that lets you see spikes, diagnose things like memory leaks, and really understand the actual behavior of your cluster. This is the raw material for observability. But let's be honest, raw data is pretty useless on its own. To make any sense of it, you've got to visualize it. And that's where Grafana comes in. It is the go-to partner for Prometheus, letting you build these rich, beautiful, informative dashboards that give you that at-a-glance insight into the health of your entire system. All right, we've covered collecting and visualizing data. That's huge. But what if our monitoring system could do more than just watch? The operator pattern is what takes us from this passive monitoring to very active management. Just look at the contrast here. A standard Prometheus setup, it's watching from the outside. It collects generic stuff like CPU and memory. An operator, on the other hand, is an application-specific controller. It has expert knowledge baked right into it, so it can actively manage the application's entire lifecycle. The key takeaway is this. You go from monitoring the application to having an operator that monitors and manages it. And this is a perfect example. KubeRay is an operator for the Ray Distributed Computing Framework. It doesn't just watch Ray clusters, it creates them, it auto-scales them, it handles failures for them. The operator literally becomes an automated, expert sysadmin just for that specific workload. So this all brings us to one final thought, one last question. As you're building out your own monitoring strategy, ask yourself this. Are you just collecting a bunch of numbers and storing log files? Or are you building a system that gives you deep insight, that lets you ask any question of your cluster, and that ultimately enables the kind of automation that is the true promise of Kubernetes? Because the goal isn't just data, it's understanding.